Assalamu alaikum. I'm Istinub Azad, ID 18101045. The project we're working on is to devise an interface of a device called the fitness analyzer. The functionality of the device is it will display some values based on paddling in a cycling exercise machine or any sort of device with the same system known as the system of spin bike. Here, we used Arduino Uno as our microcontroller, where we connected two sensors with it to get our expected results. There is also a terminal window device to monitor the values, and there is also a COM pin device to connect with interfacing with the LabVIEW. Both the sensors have a potentiometer connected. At the VCC's pins of the port is connected with the power supply source, and there is the ground GND pin is connected with the ground. Further, we added an inductor and a capacitor with the MQ135 sensor to get a better and precise value. The heartbeat sensor will display the pulse rate of the human being using the device, and the MQ135 sensor will display the carbon dioxide level to determine the air quality of the environment. Both of the sensors have their output pin connected with the analog input pin of the Arduino, which is the A0 pin. Here, the COM pin is here connected with the physical port, the COM2. So this was our circuit configuration of the device we are designing to create. Next, my teammates will explain the code, program, and the user interface. Thank you.
Welcome to our project presentation. We are assigned with the project named LabVIEW based fitness analyzer. I'm Palash. My ID is 1810153, and I'm going to describe the coding part. So before describing to describe the coding part, what we did here, we imported the pulse sensor library, and we also declared some variables for our convenience. And here in the pulse section, what we did, we also declared the variables, impulse variables, metric constant for keeping the metric constant value, calculate the distance, keeping the distance, calculating the time, and determining the speed. And also, as we will be calculating the calories, here we took a variable named n calories, and we also calculating the value, taking the value from the carbon dioxide from the environment. So also we took a value for instant, and as we also will be determining the battery percentage. So here we also took a battery variables. So to begin with, you can see we are communicating with our board, Arduino board, in 9600 band. And here what we are doing, here we wanted our built-in LED of Arduino to blink with the heartbeat. So when we are reading the heartbeat, we are also blinking it with the heartbeat. So that's what we did here. So before going to this part, I want to say, as we didn't have a spin bike, so what we did here with the loop, we just increase the impulse rate. For each loop, we considered it as each paddling. That is how we calculate the impulse. And we also, by calculating the impulse like this, it will be increasing in time. As we didn't have any option, so we did it in this way. So to go on, here what we did, we took the values from our sensors, heartbeat sensors, and we calculated the BPM, and we also took the value from the sensors, and the gas sensor obviously to calculate the carbon dioxide, and and then we printed the carbon dioxide level at our CL monitor. And here what we did here in this part, we wanted to see the BPM in the monitor, and obviously if anyone is connecting the sensor with himself, then we'll getting the BPM, and if not, then we are printing not available. And this is how we did all the coding parts, and that's all from me.
Assalamualaikum, I'm Tasnova Ahmed. My ID is 19101462. Now I'm going to describe about the LabVIEW part of our project. So here is the block diagram of the LabVIEW part. As we are showing 6 outputs in this project, so we use 6 VISA read in this block diagram. So here is our 6 VISA reads, and every VISA read is connected to string to number converter and also connected to this build array, and every string to number converter is getting its value from its corresponding block. So here is a heart rate block. This heart rate block is giving values to this is string to a string to number converter, and this value is passing through this line to this build array. And we have a build array of 8 index. The first two index is for time and date, and the other 6 is for carbon dioxide, calories, power, battery status, heart rate respectively. And also we are using a time delay function. So here is our time delay function, and it is taking input after every 600 millisecond. And also we have used a visa close and visa flash here, and the whole mechanism is under a while loop. And now I'm going to show you the front panel. So here is our front panel. In the front panel we have 6 diagram for the 6 outputs, and also a thermometer for carbon dioxide max level. And we have also used another alarm for this carbon dioxide max level. Whenever it cross its level, whenever it cross its level, it will give us a alert. So to run this file, we have to choose a port name. So we have choose port 1, and now I run the project. And also I need to run this Proteus file as well. So here I run this Proteus file. So after click on this Proteus file, we can see the values in this virtual terminal also. So in the LabVIEW part, we can see the values of our variables. So the first column for carbon dioxide, so we can see the value of carbon dioxide, heart rate, speed, calorie, power, and also battery. And whenever carbon dioxide cross its level, it will give the alarm here. And also in the graph, we can see the changes of the values. We can also control these values from this Proteus file. So here I'm changing the percentage of heart rate. So here I changed, and also gas. Also I'm also changing in this gas sensor. And we can see the changes of values here. So yes, the value is decreasing. Carbon dioxide value is decreased to 93 from 86, as I decrease the value at least the lower level. So it's all about our project. Our project was to show the fitness analyzer of a person of the spin bike. So we have showed all the values which is mentioned in the description of our project. So thank you.